Welcome to another RDWorks Learning Lab. Well, today is the day. Freshly arrived from China, the Universal Engraving Nozzle. And today I'm going to show you how we're going to turn this into the compound nozzle, or what it claims to be, a universal engraving nozzle. And we're going to see how and where it fits. But before I do that, as with anything that's being sold, there is a beware the catch clause. Yes, I designed this in all good faith, but it's designed for a specific purpose. The purpose is photo engraving. Now, it will also do other sorts of engraving as well, but that wasn't the intention when I designed it. This will hold all sorts of lenses. They will all be 18mm diameter lenses, so make sure you remember that when you order your lenses. But it doesn't guarantee to make you into a super photo engraver. There are several other things that you need to build into the equation before you can get really good quality pictures. Number one is your own ability and experience. I'm not being rude or nasty about that, because you need to experiment, as I've demonstrated to you on many occasions, to get the best quality dots that you can. I'm providing you with a piece of equipment here that guarantees to get good quality dots under certain circumstances. Now, the certain circumstances are: one, using the correct medium. Perhaps that should be media, because I don't think the medium will be very happy if I put dots on her. And number two will be the power that you've got in your machine. Now, if you've got a really powerful machine, like a 100 or 150 watt machine, I really wouldn't advise you going out buying this compound nozzle for doing photo engraving, because you just won't have control at the bottom end of your power range to get the precision dots that you're looking for. It will work perfectly okay, this, for normal engraving. By that I mean to say text and logos, just ordinary black and white plain level engraving. And this will also work well for probably 3D engraving as well, although I haven't tried it yet, but I do intend to test this for 3D engraving as well. So there is no guarantee that you're going to be able to make a business out of photo engraving. You're going to have to practice, but I'm giving you the tools that should make you capable under the conditions that I've specified. Now, one of the key things that I'm going to be using for, and I always do use for testing and evaluating the lens, is some special paper. Now, this paper, as you can see, is basically a watercolour to watercolour pad, in fact. All right? It's a very nice thick paper, which is, as it says here, it's 200 grams. So it's quite a thick paper, a thin card. It takes a good dot, and it displays the various powers if there is any leakage of power around the dot. So you'll get a black dot in the middle and a brown halo around the outside. Now, that's great, because what we really want is a dot that doesn't have a brown halo. That's what we've been working towards. Here I've got a lovely white card. It's again about 200 grams. But this is really not suitable for engraving. It looks fantastic because it's great, it's white and it's smooth. And here we are. It's produced quite a nice picture on this white card, but it looks a little bit lacking in colour range. It's very drab, very faded. And there's a good reason for that, which I'll explain in a minute. Now, here I've got another card, which is 1 millimeter thick, and this is the card you see me using all the time. This is what I call beer mat card. If you look it up on your own eBay, you can probably find it from a craft store somewhere. You can get this card. This particular card that I got, as you can see, it's a little bit on the curved side, as though it came off a large roll of some sort. I've also got other packs that I've bought which are completely flat, and that's really what you're looking for. But the paper itself is a really crude pulp. There's virtually very little that's been done to this. It's almost grainless wood. but it's got what I call a very low damage threshold. It will burn much easier than this stuff. The images that it can produce, with the same power settings by the way, are a world different. Now the reason why this one is so faded is because this lovely white smooth card is filled with something called kaolin. And kaolin you'd probably know better as something called china clay. It was called china clay because Kaoling, with a G on the end, was the place in China where it was originally found and mined. And this paper is loaded with probably maybe as much as 40 or 50% china clay. Now, as we remember back to the days when we were trying to engrave on mineral materials, effectively that's what we're trying to do here. We're trying to engrave on a mineral, not the paper. The burning of the paper that's within this mixture is being suppressed by the actual china clay itself, which doesn't want to burn. All I'm saying is choose the material that you want to work with carefully. We'll talk about wood itself later on. Now I've got the same material here, but one thing that you'll probably notice is this is significantly blacker than this one. This one has got a brown tinge to it, whereas this one has got a much crisper, wider tonal range to it. And that's one of the things that comes about by having a really crisp, sharp black dot. You do not want the brown tinge around the edge, because the brown tinge around the edge tends to drag your eye into a different colour range. This is what we're going to demonstrate to you today, how I got to this picture. Wasn't difficult at all. So when you order a universal nozzle assembly, here's what you're going to get. You're going to get a nozzle which has got a 6mm hole in the end, and it will have a 3.8mm hole in the side, and you will be supplied with probably something like about a 6-inch piece of 4mm diameter polyurethane pipe. And this piece comes with it as well, which is its clamp ring. That's what you get if you just order the universal engraving nozzle. If you order a compound nozzle, then what you'll get in addition to that, you'll get 2 lenses. Now one of these lenses is a fairly cheap Chinese PVD 1.5 inch 18mm diameter plano convex lens, and the other one is a rather expensive American CVD lens, which is 18mm diameter again and 2.5 inch focal length, 63.5mm. What we need to do is to assemble this in a certain order. So we'll take our nozzle, and we first of all, with the flat side downwards, or the concave side downwards, we'll drop the 2.5 inch meniscus lens into the bottom. And then on top of that, we'll drop the 1.5 inch plano convex lens. Although you can now screw the clamp screw in there like that, I personally like to put an O-ring on top so that I get a little bit of compressive feel to the clamping system and I don't overstress the lenses. Because bear in mind, these lenses are not flat. They've got a void on either side, so if you put pressure on there, there's a possibility that you could crack the lens if you put too much pressure on it. So I would much prefer to put an O-ring on top of that to take some of the compression. Now, as I've just shown you, that O-ring doesn't really fit in there. It's a bit on the snug side, but there are no rules in this game. And so what we're going to do, we're going to modify this O-ring, and we're going to take, say, 1/4 inch out of it. Okay. Now it fits. And it's not that difficult to get that O-ring out of there, as you can see. All right. Now when I tighten this little nut down on top, I can feel it just snuggling up and stopping everything from rattling, and there's a little bit of tension on there so it's not loose during the shaking action of engraving. Now at this point we need to put a little piece of this 4mm in the side here, because this is your air assist. Now it's not a struggle, but it's got to be a snug fit, and if you look carefully inside this hole you'll see that there's a little obstruction at the end of the hole which prevents you from pushing this tube right the way through into the bore where you could melt it in the beam, and it will work well in this new head that I've got. Now when you're using it with this assembly you probably have to remove the O-ring. There's not enough thread inside there to gobble up everything that we need to hide. So clamp the lenses in, but this time you need to be very careful. Just tighten it up just enough for it to lock, and then we'll find that we should be able to pop that into that assembly there. So you can use this compound lens on virtually any machine because it's just a nozzle. It doesn't depend upon the machine configuration itself, whatever lens tube you happen to use. Okay, well because I'm going to be using this on this machine, I'm going to go back and just put my O-ring in here. Okay, now we've got our lens, compound lens assembly mounted in the bottom there. I normally have a short piece of tube which I pop in here, and that allows me to connect these two pieces together, and you can cut this off to suit your particular configuration. One of the most important things you're going to have to do to your machine before you start photo engraving with this particular type of lens is to make sure that your table is set uniformly level, and I don't mean water level, I mean it's the uniform distance between the table and the end of your nozzle, because we can't afford to have too much variation in the focus depth, because we're not cutting here, we're actually trying to produce very accurate dots on the surface of the material, and the height of the work makes a big difference. So most of you guys will have one of these things, and if not, just send me an email address and I will get you the drawings so that you can make one of these for yourself. This is a gauge which enables you to measure the distance between your nozzle and the work table, and at that point there I've got 15.5. Again, I've got 15.5, but down at that front corner there I've got maybe 15.6 or 15.7. Well, no, I've got 15.7 again, so I've got about 0.2 run on that table from back to front. Now 0.2 is not a serious amount, because I'm not going to be using the whole of the table, I'm only using a small part of the table. So the maximum amount of variation I'm likely to get across my work is somewhere in the ridge of about 0.1 of a millimetre variation in height. But it's got to be at that sort of degree of accuracy to get the results that I'm going to demonstrate to you. Now I've made lots of little test squares here out of the watercolour pad that I just showed you. We're trying to get something better than 0.5 millimetre position to find the most accurate focal point onto the surface here. And this is about a 60 watt tube in here, and I'm using it at 14%. So we're probably around about, if I look on the chart, probably around about 10 watts we're doing this test at, and we're running it at 200 millimeters a second. Now maybe that's too fast, maybe it's not. We shall find out when we start doing the test. Now I know that this is approximately 10.5 ideal focus, so we're going to start off by running this test at around about 9.5 millimeters, and we'll do the test. Now you'll hear that I've got air assist on there as well, so what I now need is my little inspection lens. Because we need to take a look at this, and to be honest it's pretty rubbish. So let's go to 10.5 millimeters, and all of a sudden that becomes superb. Crisp, clean, no burn marks. For those in between situations, we've got whole numbers as opposed to 10.5, etc. So the difference between these two gauges is basically 0.5 millimetre added to the bottom, 11 millimetres. And that's looking pretty good as well. So both 10.5 and 11 millimetres are excellent. Okay, so somewhere between 10.5 and 11 millimetres gives you a very, very good dot. Now, I think you can probably see there, just with without me going any further, the colour difference between those which are brown, which are scorched, and these in the middle here, which are perfect, which are black. So all you're seeing here is the black dot, the hole that goes through to the other side. Maximum power, pierced right the way through the paper. Now, the whole reason for having this pattern is not only so that you can get the best focus that you can, and the bottom line of that pattern has got pixels on it which are 0.1 of a millimetre wide, with a gap of 0.1 of a millimetre between each pixel. So there's a pixel missing, a pixel and a pixel missing. But that enables you to use your magnifying glass and make an assessment of the dot size itself. If you can see a gap between the dots, which is the same size as the dot, then you've got a 0.1 dot. And I've certainly got a 0.1 or better dot on this little pattern here. Okay, now I've just imported this picture, and we need to just go and take a quick look what the bitmap handle says. Now if we take a look here, the bitmap handle says the resolution, the native resolution of this picture is 300 pixels per inch. 300 pixels per inch is greater than the intended resolution that I want to get to. I think that with a 0.1 dot I will be able to get 254 dots per inch. Let me just prove that. Very simply, 1 inch is 25.4 millimeters, and if I've got a 0.1 divided by 0.1 equals 254 dots per inch is what I'm likely to be capable of with that lens. Now 254 dots per inch means I need 254 pixels per inch on my picture, because every pixel is going to be represented by a black dot when we've finished doing the preparation of this picture. Close this down and rescale this picture because it's bigger than what I want. Now you must do the scaling first. Here I've got 241 millimeters wide, and I want that set to about 180 because I've only got an A4 size sheet of paper, which is 210 wide. So I'll set it to 180. 180. Now if we go back and look at the bitmap handle, remember this picture was 300 pixels per inch when we started. Now we've reduced the size of it. What's happened is RDWorks has not removed any of the information. What it's done, it's increased the resolution of the picture. So we set the output resolution to 254, and we'll do a dither, and we're going to do a dot graphic dither. Okay, and it doesn't look any different. We're going to apply it to the image as well. Now we can see at the top here, before we change anything, we have changed the resolution of this picture now to 254. Okay, and this picture here is also 254. There we go, and it's dithered with all those little black and white dots now. So every black dot is what we've got to print. We don't want to print brown dots, we want to print black dots, because it's the black and white density of this picture which gives it its apparent grey scale, even though we're only working with one colour, black, on a white background. We've got to set the speed to the same as our test, because there's no point in setting the speed different than what we tested at. We tested at 200. We're not going to have any blowing going. We are going to scan. The speed that we did our test at was 14%. So across here we're going to do X swing, and we know, oh already look, we've got 0.1 already set for the interval, which is the dot size, 0.1. Okay, so not only are we going to have 0.1 dots this way, we're going to have 0.1 the other way as well. All we've got to do now is set up our paper and go for it. Now I've got my nice steel flat base plate in here, which works extremely well for most things. But when I want to do this detailed engraving, one of the problems that happens is, even though I've got this fairly thick 1mm card, which you think would be very stable, when I clamp it down on here with magnets, as I start engraving, the paper starts to expand and do silly things. And so by the time I get to this point here in the picture, something strange has happened. Like this. The middle has begun to come up. And it can't go anywhere because I've clamped it down with magnets round the edge. So we get the middle actually rising up. And I don't know whether it's just relief of stress on the surface here or what, with all the stuff that's going on. It can't be heat, but something is happening to the paper that causes it to rise up. So when I'm doing this sort of work now, what I've found I had to do to get successful results is to make myself a little A4 vacuum table. As you can see, I've got 6 fans underneath which are drawing air down and blowing it out underneath. So here we are with a piece of my nice flat beer mat card. Just pop that on there, and look, there's no movement anywhere. It's sitting nice and level. Now we can set this up to 10.5 or 11mm. It really doesn't matter which we do. When I've manufactured this bed, I've put a 3-point location system on it. So I can jack these 2 points up to get them level front and back. And then I can start from this as well, let's just do it, 10.5mm. We can come forward to the front. And I can set that up to 10.5mm as well. So back to front is spot on. And now across the side here, 10.5mm. Now it's an absolutely perfectly flat plane on which I'm going to engrave. Now just before I send this picture down for printing, I've got one other thing that I want to do. And this is quite an important thing that you ought to remember. We come up here to config, and we're going to do system setting. I've got my datum in the right place here, but my head is not in the right place. I would like my head to start and the program to start down at the bottom in the center. So I say close, and if we look now, you'll see that my green square is down here, and that's where I'm going to start, and I'm going to work my way up the picture. That way all the fumes that are lifted off as I'm engraving will be in the air and blowing upwards. They will not try and contaminate the picture that I'm leaving behind. So I should get a nice clean image as I work up towards the top where my extraction is taking place at the back of the machine. Now I'm going to turn the extraction on, and I'm going to close the lid because I want the air to flow backwards. It's not flowing backwards at a very high speed at the moment, so I need to make sure that it's flowing back quickly across the work. So now the air is going in through this slice here, and I can feel it being drawn in, and it's going back quickly across the work to take all the fumes backwards as quickly as possible. We've got no loss going down through a honeycomb bed or anything like that. It's going back across the work. And I keep stressing that because so many people think they're going to get good results with a honeycomb bed. block it off with a piece of cardboard if you're going to do engraving like this. Make sure that your airflow goes from the front to the back of your machine. Just hoping that you can see the speed with which the smoke is being drawn away backwards. It's never getting a chance to settle down on your work. Now, just to prove that I'm not actually cheating, this is happening live with the same nozzle, compound nozzle system that you are going to be able to buy. I'm doing this picture at 254 dots per inch. The one that's over on the right hand side there was done at 200 dots per inch. It's already pretty good, but if we look at this one, which is happening at 254 dots per inch, that is hardly any different than a photo reproduction. So, as I may have mentioned to you before, high quality photographs in magazines are printed at around about 300 dots per inch. We're doing 254 here. Why on earth would you claim to be able to do 1,000 dots per inch when I've proved beyond doubt that that's impossible? Here is some very, very impressive results with 254 dots per inch, which is easily achievable with the right material with this compound lens. Then we'll turn the vacuum table off, and I think you have to admit that's pretty impressive. You can count all the hairs in his ears. You can see his nostrils. Even though possibly maybe I should have worked in Photoshop his nose just a little bit to bring it up so that you could see the nostrils slightly clearer. In other words, lighten the nose just a little bit. No, I'm putting my fingers across here and I'm not feeling any 3D-ness. If you can feel 3D, you've got overburning of pixels. I don't appear to have any overburning of pixels there, which is the ultimate goal for this sort of work. Now, this is a very sensitive, low damage threshold material, so we only need a small amount of power, 14%. Now, this is wood pulp, but it's not the same as wood. So how are we going to get on for wood? Because most of you guys want to do things in wood, not bits of cardboard. This appears to be a fairly popular material, 3mm thick Baltic plywood, Baltic birch ply. Now, the problem with this stuff is it's definitely not flat. It can be distorted all over the place. And look, we've got more than a millimetre of movement here. So this is not going to be very good at all for doing our pictures on, because it'll go out of focus. So let's just try and see what happens when I turn this. Better, but still not really good. Now, I did have another variation of this table, which was driven by a vacuum cleaner in there, and it really sucks down hard. The only problem is it plays hell with your ears, all the high whistles that happen, and I decided it's just not worth it. I'm not going to throw it away, because just maybe one day I shall need to use it. I really have only bought this wood to find out for myself what you guys do. I don't need to do it because I'm not in business, but hey, we need to prove on this material how this system works, and I've not done this before. So we're going to have to tackle this problem in a slightly different manner. I know that this table is flat within 0.2 or something like that, so I don't have to worry too much about leveling it up. But what I've got here is a stack of Neodymium Magnets. These are extremely powerful. I mean, this is how powerful they are, look. Now, These things are brilliant because I can mount these down on my steel table. So I'm going to put them down on the table at approximately the corners of this wood. What we've got to see is that this wood is very slightly rocky this way. And so what I'm going to do is to put a couple of these down the middle of the wood to stop the wood from going downwards when I pull the corners down with these magnets. And everything is nice and flat now. We need to do the dot test again. Now this time we're not looking for the focus because we know what the focus is, it's 10.5mm. What we're looking for is parameters that give us good quality dots. We'll use the same parameters that we did last time. Well, they're actually quite nice dots, but they're not particularly dark. I can see, I'd say they're about 0.15, those dots. How do we get the dots smaller and darker? Because they're not very dark at the moment. If I slow the machine down, I will allow each dot to burn a bit more. And if I change it from 200mm a second to 100mm a second, I know that I've doubled the amount of energy going into each dot. So that's the first thing I will try, but the risk of that is that I'm going to increase the size of the dot because I'm going to allow it more time to burn. Now, I don't think there's any doubt you can see that the second set of dots are darker than the first set of dots. Question is, what size dots have I produced? Actually, the damage is not as bad as I thought it was going to be. I would say that they're still around about 0.15 dots. That's one way of doubling the power per dot. The other way is to increase the speed and double the power. 14% is about 20 watts. If I want to go up to 40 watts, I've got to go up to around about 20%. And I would say that halving the speed is a better option than doubling the power. Now, I have to say that 14% on this machine is towards the top end of my pre-ionization zone, the high frequency impact engraving zone. So I'm still in what I call hissy mode when I'm doing these dots. So we've looked at the dot size now, and we know that the dot size is around about 0.15. As I've mentioned to you before, having a small dot is great on the right material. That does not mean to say that you will always be able to use a small dot on any material. And here's a case in point. And we found that we've got dots of around about 0.15 is the best that I can get. This was done at 254 dots per inch because I could achieve 0.1 or better dots on this media. I can't achieve that on this wood. The wood determines the resolution that we can work with. And if we can only get 0.15 dots, then I'm afraid we're stuck with 25.4 divided by 0.15 equals 170 dots per inch. So that's the resolution that we're going to have to go back and set RD Works to. We're going to have to reset it to 170 dots per inch, which is a dot size of 0.15. That's going to take some time, so we'll leave that cooking, should we? Well, from this distance onward, it sort of looks quite acceptable. Right, well, now we get a bit closer, we can see all the dots on this one. It's not particularly good, is it? But the great thing is we can actually see the nostrils on here. There's no hint of 3D-ness about this at all. So maybe we could have increased the resolution. Perhaps we'll run the same thing again at the original 254 DPI. think we have to admit that that's pretty reasonable for a piece of wood, and they're just the merest hint of some 3D-ness on these really black pieces, but considering I thought that this was going to be badly overburnt, it's not that bad at all. So wood seems to be quite a good material to use after all. I thought it was going to be more difficult than that. That's not bad at all, is it? Here we are at the end of what I think has been a very productive session. Everything that you want to know about these nozzles and the compound lens, where you can order it from and what you order, is given as a link in the description below this video. As I've demonstrated today, it's not difficult to get excellent quality pictures. You just need a little bit of thought, a little bit of care, and some experimentation. And look, the results are staggering. But bear in mind one important factor: downscale. Don't upscale. You can't make something out of nothing. So there's no confusion at all. Here's what you're going to get when you buy a universal engraving nozzle. It's just going to be the nozzle, the clamp ring, and the piece of tube that goes in the side of the nozzle. But when you buy a compound lens kit, in addition, the lenses that go in as well as a complete little kit. Now, if you have a machine that uses the 18mm lenses like this in the nozzle so far, then you'll be able to replace your existing, let's call it a cutting nozzle, with the universal engraving nozzle, which will fit in there like that. And you'll be able to use all of your lenses, 18mm lenses, in the way that I've shown in this picture. Now, if you happen to have 20mm diameter lenses in a system like this, you will still be able to use this universal engraving nozzle, but this time you'll not be using the clamp ring. You'll either be mounting the lens at the back, as I've shown here, or right at the back here for a 4-inch lens, or if you've got a 63.5 or 2.5-inch lens, then you'll be able to mount it directly on this top surface here. Similarly with the 2-inch lens and the 1.5-inch lens, you'll mount your lens directly on top of this nozzle. You'll use the adjustable clamp ring as a backstop, and behind the backstop you'll put an O-ring in there just to give you a little bit of a compressive feel to when you tighten the whole thing up. Well, I think in a future session we're going to have to take a bit of a look at this thing that I devised, which is the vacuum table, which I think will probably be quite an essential piece of kit for some of you guys. Well, thanks for your time, and I shall see you in the next session. Bye.